All right, I'm about to take you deep, deep into a Collins 51J-1, the model that doesn't exist. Here it is. It uses bandpass filters, mechanical bandpass filters. Mechanical in the way it tunes each coil. Because some guys go, it's not really a mechanical. Mechanical filters have crystal filter. Blah, blah, blah. So there are three coils. One, two, three. You can't see the third coil until I bring it up. But this is band 4-7, bands 8-15, 16-30, band 1, 2, and 3. Its front end coils are over here on this rail, and they work with the main tuning. And also on this rail are the what they call the variable IF. And there's two IFs, one for the even bands and one for the odds. This radio, to really understand it, to get as deep as I've gotten, would take you working on it about an hour every day for about a month. But I just want to show you this bandpass filter section. Now, you can online, you can buy, a guy sells a circuit board, and you can wind your own toroid coils. It takes 3 toroid coils, and you can create a bandpass filter. And that's what this is. It's exactly this old technology done with toroid coils. And these only tune to get into the band. They don't move after that. In other words, once you switch your band, these things move. I'll show you that. But they don't move after that. After that, the tuning is done with the main tuning oscillator, which would be the PTO, and other units that switch in when you change the band. And the IF moves. Uneven IF. When you're on an even band, the even band IF moves. You're gonna have to look at the schematic, but what I'm zeroing in right now on this video is these are bandpass filters, and there's band 4 to band 30 are right here, and they move. They all seem to be moving, but I'll explain that. In other words, right now we're on band 3, and this one's gonna start moving, but these also move. But this is the one that is actually active. Right now we're on band 3, and as soon as we go to 4, see it's going down, but now it's going to come back up. Okay, so this should be 4, 5, 6, and then band 7. Now it might start going back down on 8. Up, and now it's going to go back down. In other words, they're on a gear system, and there's cams in the back, and the gear system doesn't stop turning them. So what they did was, okay, we're going to have a bunch of gears that are going to keep moving. So these other two, even though we were just using this one, these two keep moving because they have to, because they're using the same gears. And the reason they did that was just to save on the complexity of this unit. But modern receivers have some kind of bandpass filter on the front end off your antenna. You come in the antenna, from the antenna, you go to your RF amplifier, and then you go to 2 more coils, which basically eliminate any signal that got past the front. So you come in the front end to the first coil, and it only lets that frequency through that you got it tuned to, or band. In this case, it'd be a band. So it gets amplified. Now, to make sure that other products didn't get in, you have 2 more coils that shunt out and only allow the frequency band that you're in to come through. And so these are bandpass filters. And the modern version, if you go online, there's a guy that sells ones wound with toroid coils. There's 3 coils. Now, if you go look at my video, I have one with 3 coils, and it's tuned with varactor diodes. So I can make my unit operate just like this. In other words, I can change the voltage, and I can change the band that the bandpass is set for. So I've emulated this unit. Now, by buying this radio, I understand that they only did a few frequencies or a few sets of frequencies and bands. So it's got 4 to 7. So it's be 3, something like that. So it does 3 bands. Right, 4, 5. Okay, 4 bands. And I had to do the math in my head or on my fingers. Basically, this technology is still being used. Now, on your SDR radios, there is no front end on most of them. There's a cheap little coils. That's why they're garbage. I get a lot of people upset when I say SDR radios are garbage. But I had to have this radio because this is what I was getting into. A 3-tuned front end, 3 coils that are tuned. Now, once mine I can switch with just changing the voltage to a different band. And in this case, let's go backwards now. In this case, they're moving them up and down. And you're saying, well, what's actually happening? Well, on this is adjustable. There's also a capacitor down in there. There's a wire with a ferrite slug that goes in and out of a coil to change the frequency. And remember, we're moving bands. We're going from band 4 to 7. So as this goes up and down, it changes the frequency of 3 different coils. It'd be just like using my unit, 3 different toroid coils and changing the voltage. This is done mechanically. I can do it with voltage. It's still the same electronically, the overall what you actually get out of it. But I just wanted to show you that this radio, it takes a while to really learn how it works. And here's I think you can see and I cut my nails, my 3 IF cans that I cleaned up as best I could. I got the radio fully functional. You know, I could turn it on now. We're on the wrong band, I guarantee you. We're going up to the AM broadcast band. Should have something. It's warming up.
The other thing, a friend of mine mentioned that her sister has chickens, and she put a pumpkin in for her chickens, and they talked about it all day long and pecked at it.
So I went past resurrection on this radio because I didn't want to just put it away with a lot of things still wrong with it. I went in, I told you I cleaned the tracks on the wafer switches. That's what was really wrong with this radio. The tracks on the wafer switches were dark black and they were conductive. And what was happening was some of the signals were going through the carbonized material on the copper. And I was getting low signal on the AM broadcast band. And I emailed the guy and he come back. He didn't understand my question. I emailed him again. And then he referenced me to the manual for a different model. I told him I have a -1. And anyway, I finally went and looked at the manual he was looking at. And they do knock down the sensitivity on the AM broadcast band on this radio. But after I cleaned the wafer switches, I got more signal, a lot more signal. See, I had signals. See, the worst thing that can happen to you is you can have an intermittent, which I had on this radio. The other thing too is you just have low signals all the way through. And you could pull the tubes out and test them and they test good. In my case, I moved them around. And it turns out to be something you've never seen before. And what happened was, I could tell the guy was in here, or many people were in here before me in the same sections. They would take shields off, and they'd go in, they'd spray the switch. And then they put the shields back on. In some cases, they only put some of the nuts back on, or some of the bolts back on. And it really didn't fix the problem, it made the problem worse. So I went in there, and I showed you my eraser pencils, and all the tricks with the hemostats, and the locking pliers and the whole, and I cleaned it, and all of a sudden I started getting more and more signal. So, you know, if you take a signal injector and you put it through this radio and you have bad wafer switches that are conductive but not the way they should be, you're going to follow the signal all the way through the radio. And if you don't have schematics that tell you how much signal at each point you should have, you go in circles. And I finally said, let me clean all the switches. Let me just, and it was very boring. Every day I'd do a couple wafers, 1 or 2 wafers, because you have to come in at different angles. You got the locking pliers. And I did it. And then the radio started coming to life. And that's what was really wrong with this radio, was over the years, whoever owned it just kept spraying those wafer switches. And the last person that had this, I think, put WD-40 on the wafer switches. And in some cases, that crud, that black stuff, was actually running like tar. That's what was wrong with the radio. The PTO was fine. And I just wanted to show you that this is a bandpass filter system done with coils, and it uses ferrite rods that go in and out of them to tune, just like a car radio. And these are always in motion because they're on a cam, and they're all hooked to the same gear system. And in order to make it simpler, they didn't put any places where the cam would stop moving, and then only this one would move, and then when you went to the other, they kept it fluid. So in other words, your adjustment would always be ready to go. So as this one would be, let's go again, let's do it again. As that one's going down, notice that one's going with it. All right. Now this one's coming up into play. Now the next one's going to go. Now it's coming. It went to the lowest frequency, and now we're going up in band and frequency. The slug is coming out of the coil, and now as we go up, now they're both still moving. They have to keep moving because they're on cams. Now the final one should start. We're going to go up higher in frequency. The final filter, bandpass filter, is now for going up to band 30, and then over here, this one does not move. The IF one does not move unless we turn the. It moves, but much slower. I don't know if you can see that. Wait, make sure we're in the band. Yeah. Let me get centered here. This one moves with the main tuning, and on here is your AM broadcast. There's only 2 slugs for the AM broadcast. One antenna ends back in here. Antenna in, and then I think the other AM's over here. It's got band 2 and 3 front end on here, and then it's got the 4 IF coils. 2 coils are for the even number bands, and 2 coils are for the odds. It's amazing, and you have to read up on the different mixers, and on the AM broadcast band there's 3 mixers. On bands 2 and 3, there's 2 and 3. There's only 1 mixer being used, and in bands 3 to 30, it uses 2 mixers. So this is a dual conversion radio, except for 2 bands, and so it's not really a dual conversion radio. There's should be an asterisk on it, but it is what it is. But that's how they do it. And if you look at an R71A and ICOM, they use diode switching. And they have a bunch of coils, and they switch them in and out for different bands. They have a little bandpass filter for each band. And as you're tuning the band, it's the microprocessor is switching the coils in and out. And they don't use toroids. They use these little tiny ones, which are even less efficient. In order to get really good selectivity, you have to have coils with really good Q. And these coils here have good Q. They're larger in some other radios, but these are good enough because you got enough amplification. See, the older radios had to have larger coils to get better Q because the tubes didn't have quite the amount of gain. And then they didn't have, for selectivity, they didn't have crystal filters that you could put in the radio. And these IF cans, all 3 are the same, and that's because they're relying on this IF system. This over here, this unit here is you can vary the bandwidth of the radio, and there is a plug-in that can go in the newer models of this radio. I think that's about it. I just wanted to show you that, and then this blew my mind. See, when I started moving this up and down, I thought maybe the 3 coils went this way, and then I realized, I said, why did it keep moving? Well, the mechanism it's on there's less involved if you keep all three moving, but then make the cam do the change. So it doesn't matter if this is moving because it's not switched in with the wafer switches. See, that's what you got, both coils that are moving between band changes and wafer switches. So if any of those wafer switches are tarnished or bad, you're going to lose a band. In this case, the wafer switches for this section, you'll lose a band. And anywhere else, you might lose the whole radio might not work. Like say, or you get like in the IF, if you lose one of the IFs, you only get the odd or even bands. This is really tricky, and if you really want to get into it, it's going to take about a month of reading. I don't know how much time you put into it each day. I'm 71 years old. A lot of times I just walked away from this thing because it cost so much money, and I just had to know how they did it. And I was on the track. I was on the right track. If you go back and look at the me building a dual conversion, which ended up being a triple conversion radio with the NE602s and toroid coils and varactor diodes in some case, a Franklin oscillator, a digital readout from eBay. I got basically built two bands of this radio using the schematic. I'm like, well, let me put in three coils on the front end, and then after the first coil, let me put my amplifier, and that's how this works. Signal comes in from the antenna, goes to this first coil. You have the band set, so only that band can get in through this radio. Theoretically, other something that's second harmonic or third harmonic might be able to sneak through it. But then it gets amplified, and these next two coils again shunt out any frequency that you don't want in that in the spectrum. It only lets that band through. Theoretically, other things can sneak through on these radios. I think that's it. All right, that's it.